Hello guys, so we are going to continue the discussion with respect to statistics, and in this video we are going to define or understand what exactly is p-values and what is the importance of p-value in hypothesis testing. Now let me go ahead and let me explain about p-value. First of all, we'll try to see the definition, but p-value is super important in inferential statistics because it will help us to make some conclusions about some population data. Okay, now before wasting any time, let me first of all go ahead with the definition. So over here, a p-value is a number calculated from a statistical test that describes how likely you are to have found a particular set of observation if the null hypothesis were true. P-values are used in hypothesis testing to help decide whether to reject the null hypothesis. Okay, not a worry like if you are not able to understand, but I will give you very good examples regarding p-value. Okay, so let me go ahead and let me explain you. I hope everybody has probably used a keyboard, right? In keyboard you have a space bar. So this is how your space bar looks like, right? Most of the time with respect to this particular space bar, you touch it in this region, right? In this region, right? Most of the time you touch in this region, and specifically hardly you touch some of times over here, here, or here, here, or here. So if I probably try to see this touch distribution is also like a Gaussian normal distribution, something like this, right? Now within this kind of distribution, let's say one of the data point over here, if I say my p-value is 0.2. Now what does this basically mean? This basically means out of 100 touches in this space bar, 100 touches, we touch around 20 times in this region specifically, in this region. This is in the layman term I have explained you what exactly p-value is over here, right? P-value is basically talking about the probability of a specific outcome in a specific region in this case. Now if I say p is equal to 0.2, I'm basically saying out of 100 touches, we touch around 20 times in this specific region. Okay. Similarly, let's consider that in this region, my p-value is 0.8. Now this basically means out of 100 touches, how many times I'm touching over here? Somewhere around 80 touches, right? So this is how we can just think of the p-value right now. Okay. But let me go ahead and explain you with the help of hypothesis testing. Here I will also be taking an example for that. Okay. So let's go ahead and let's talk about this hypothesis testing. Now, as you know, in hypothesis testing, my first step is basically to write the null hypothesis, alternate hypothesis, and then we specifically perform a statistical analysis or statistical test. The outcome of a statistical test is p-value. Okay. Now, how it is related and all, I will just talk about it. Let's take an example. Let's say I want to probably do a hypothesis testing on a fair coin to just find out whether the coin is fair or not. Okay, and probably I will try to find this out by doing 100 tosses. Okay, now let's say out of, or forget about 100 tosses right now. Okay, let's consider that the probability of head is 0.5 and probability of tail is 0.5. In this scenario, we know that even though we toss 100 times, let's say if we are tossing it for 100 times, if this is the probability based on the Bernoulli's theorem, Bernoulli's distribution, sorry, not theorem, distribution, 50% of your time heads will come, 50% of times tails will come. So I can definitely say this coin is fair. Let's say if I probably go and say my probability of head is 0.6 and probability of tail is 0.4. Now in this scenario, I may consider, okay, fine, probability of head is 0.6, 60 times I'm getting out of 100 tosses. There may be a scenario like, okay, fine, sometime we may continuously get head 10 times. Okay. But if I go to the next scenario where I say my probability of head is 0.7 and my probability of tail is 0.3. Now you'll start thinking, okay, this is something wrong with the coin. The coin is not fair because 70% of the times it is basically coming as head. Now how we can probably confirm this experiment through hypothesis testing, and we'll try to see what exactly it is. Okay. So in the first step in the hypothesis testing, we will first of all define our null hypothesis. So I will go ahead and define my null hypothesis. So this is my null hypothesis. Now in this null hypothesis, I will basically say this as h0, and this scenario I will write coin is fair, because what is the basic assumption I'm going to take over here? The second scenario will be alternate alternative hypothesis or alternate hypothesis. Alternative, no, alternate hypothesis. Okay. Alternate hypothesis. So here I will be having H1 and this will be coin is not fair. Okay. This will be the opposite one, right? Not fair. Now this is fine. Now coming to the third one, the type of experiment that I'm going to perform to solve this. Let's say the experiment that I'm performing over here, I will just toss it for 100 times. I will toss it for 100 times. I'll toss the coin for 100 times. Okay. Let's say the over here, I'm just going to draw a diagram. I have 50 times over here as my mean. Okay. If I'm probably getting this x-axis is nothing but it is the how many times I'm getting head, let's say. Okay. So this will be 50. Let's say standard deviation is 10. So I will write 70, 80, 90, and this will be 40, 30, 20, 10. I have defined like this. Okay. So with respect to this distribution, obviously, you know that we will get this kind of bell curve. Okay. When I have this mean and standard deviation as 10. Now, this is obviously the mean value that I have. Okay. Now, the number of times, let's say out of this, if I'm probably getting 50, number of heads that I'm getting 50, then I can definitely say the coin is fair. Okay. Let's say if I get number of times of head is 60. Now here also I told you, right, in the above scenario, we told that, okay, fine, it is fair. 60 times it can come and 40 times tail it can come. But now what will happen if 70 comes? Like if I toss the coin 100 times and probably I get the 70 value. Now it is a concern. Now there is a problem saying that, okay, fine, 70 times head is coming, 30 times tail is coming. This coin may not be fair. So what we do is that we define a confidence interval. We basically make sure that we define a confidence interval. The confidence interval can be between 30 to 70. Let's say, how do we define a confidence interval and all? I'll talk about that. A domain expertise is definitely used over here. Okay. So in this scenario, let's say I am saying that if I'm tossing the coin and if it is between 30 to 70 number of heads in this region, okay, in this specific region, then what I will do is that I will consider that my coin is fair. So in this region, if any number comes, I will consider the coin is fair. Okay. Let's say if I do the number of tosses, now if in this region I'm coming or in this region I'm coming, I will basically say the coin is not fair. Okay. Coin is not fair and coin is not fair. Coin is not fair. Now, how do we define this confidence interval? There is a very important parameter which is called as significance value. Okay. Again, we'll learn more about the significance value. The significance value is denoted by alpha. If I say alpha is 0.05, then what it is saying is that we have to find out a confidence interval by taking this entire area 1 minus 0.05. So 1 minus 0.05 is nothing but 0.95. So this area that you are seeing, right? If I'm saying for this particular problem, my significance value is 0.05. Now you may be thinking, Krish, who will set this significance value? Okay. And how it is related to p-value. I'll explain about that, everything. Okay. Now in this alpha value, significance value is decided by the domain expertise. Based on problem statement, this value may differ. Okay. For a health problem statement, your significance value may be less, it may be more. For different problem statement, we basically define it. Okay. Now in this scenario, when I probably try to calculate the confidence interval, I'm getting 0.95. So this area is basically 95% confidence interval. And remaining 0.05 will be divided between these two areas. So in this area, the area under the curve is nothing but 0.025 and this will be 0.025. Okay. Based on this value, we get some confidence interval value. Okay. Based on this value itself, the area under the curve, we get some confidence interval value. I will show you how to calculate it. Now, let's say I get a p value. Okay. I get a p value. Okay. Now and p value is basically computed from this statistical experiment. Okay. We will be getting a p value output. Let's say the p value is somewhere coming over here in this region. Okay. Or in this region. I will show you in the upcoming videos how to calculate the p value. There will be a z test, t test. We will be doing that. Okay. And there is a specific set of specific formulas used to calculate the p value. Okay. Now let's say I get a p value and this p value is less than this specific value. Let's say this value, whatever is coming in this confidence interval. If it is less than this and if it is greater than this, it will specifically come in this region. So if I say my p-value is less than my significance value, okay, or my p-value can also be greater than the significance value at this side, okay. So either it is in this region or this region, okay. In this scenario, I will say we have to reject the null hypothesis because it is basically coming in the extreme end, in this end, or in this end. In this end, we basically reject. This is basically my rejection area. Okay, rejection area. And similarly, in this region, it is my rejection area. So what I will say, if my p-value is less than significant value, we reject the null hypothesis. And let's say if it is present in this region, okay, if it is present in this region, else we fail to reject the null hypothesis. We basically mention it as fail to reject the null hypothesis. So I hope you are able to understand what is confidence interval over here. 95% confidence interval basically means with respect to any experiment that I perform, if it is coming within this region, I will accept the null hypothesis, or I'll fail to reject the null hypothesis. If it comes in this region, I will basically reject the null hypothesis, in short, right? And this is what it is basically come. How this p-value is derived, there is a mathematical formula based on different problem statements like z-test, t-test and all. We'll try to see that. Don't worry about it. We'll try to see when the p-value is less than significance value and all. And how to calculate this confidence interval also, we'll try to see. Everything. Area under the curve, everything we'll try to see. With respect to this point, we can calculate what is the area under the curve. With respect to this point, what is the area under the curve. We will definitely be able to calculate it. Okay. But at the end of the day, this is my conclusion. This is my conclusion. Whenever my p-value is less than significance value, that basically means it is either coming in this region or this region, right? So I will say reject the null hypothesis because in this region, it does not satisfy the 95% confidence interval. Who defines this? A domain expertise.